Hello, algebra and honors algebra students. This is your video for Tuesday since we couldn't have class. It's just a little recap, a few problems I want you to try. Level 2 kids, at some point I will tell you you don't have to watch any more of the video. That's not point is not yet, but you can continue watching if you want to try to front load yourself a little bit for what we're going to be learning soon. But I will let you know when that time is. So here's the first problem. There's two systems, system A and system B. And I want you to see if on your own you can determine how many solutions the following system has. So do problem A, do problem B, and then you can watch my solutions. All right, see if you can get this on your own. We're not actually solving, we're just determining how many solutions. So if you haven't yet, please pause the video and figure it out. All right, so I don't know if you remember this, but I made a flowchart, right, to know how many solutions there are. Well, the first thing we need to do is check the slopes. If the slopes are different, I automatically know there's one solution. If the slopes are the same, I'm going to check the y-intercepts. If the y-intercepts are the same, I know there's infinitely many solutions because I actually have the same line in two different equations. They're not really different equations, they just look different. If the y-intercepts are different, the slopes are the same, but the y-intercepts are different, then there is no solution because that means the lines are parallel. So to give you a little visual, the first one solution, you might have two lines doing something like this. And there's that one solution at whatever that point is, and we can use one of our methods to solve it, right? Now, if the slopes are the same and the y-intercepts are different, then we have this situation where the lines are indeed parallel, just like that. How many times are they going to intersect? Well, they're never going to intersect. So this one here is one solution. This is 0 solutions. And then finally, there's that unusual case where you actually have the same equation in two different forms. And so one of the lines might look like this. Let me get some arrowheads on there. All right. And then the other line is, oh dear, what was that? The other line is actually the same line. Okay, and there should be arrowheads on the other end, but I'm not going to worry about that at the moment. So if you get the same line twice in two different equations, seemingly different equations, then you know that there are infinitely many solutions because the red line and the black line are intersecting everywhere. So I'm going to use this flowchart to help me do problems A and B from part 1. First, I'll check the slopes. Different, one solution. Same, check the y-intercepts. Y-intercepts are the same, it'll be infinitely many solutions. If the y-intercepts are different, no solutions. Now, if you don't have this flowchart in your note, I strongly suggest you get it in there and learn how to use it. All right, so I need to determine the slope of the first line. Well, we know this is in standard form, and remember the ABC trick, ABC. And for problem 1, or top problem in A, it's ABC. Easy as 9, 6, or 14. Okay, and then to find the slope for it, I do the negative of A over B. Oh, silly me, I don't want to put B in there. I want to put the value of B in there. Sorry about that. And that would be 6. And then I want to simplify that to negative 3 halves. That's the slope of the first equation. It's in standard form. Now I'll do the bottom equation. And again, I got to go A, B, C. Easy as 3, 2, 11. And the slope of that is the negative of A over B, which in this case is negative 3 over 2. And look at that, the slopes are the same. So I know the slopes are equal. So there's definitely not one solution. There might be no solutions, there might be infinite solutions. So I'm going to find the y-intercepts. And remember, to find a y-intercept, we set x equal to 0. So I'll have 9 times 0 plus 6y equals 14. This will cancel. I'll divide by 6. And then y is going to equal, let's see, divide by 2, I'm going to get 7/3. So the y-intercept is 7/3, or if you prefer, 2 1/3. Okay, now for the other one, again, I'll set y equal to 0, x equal to 0, and I'll solve for y. Again, 3 times 0 is just 0, it cancels out. divide by 2, divide by 2. So in this one, y is going to equal 11 halves, or you could say 5.5. Are the y-intercepts the same? Definitely not. These lines are parallel. There's no solutions. No solutions. All right. If you haven't tried problem B yet, go ahead and do it now. All right. Here I go. Problem B. First of all, got to find the slope. So I'm going to go A, B, C. Easy as 3, 1, 6. The slope is going to be the negative of A over B, which is negative 3. Now this one here, the y plus 2 equals x, isn't in any form. But if I subtract 2 from each side, the y will be isolated. Now it will be in slope-intercept form. I'll get x minus 2. And when I'm in slope-intercept form, the slope is the number in front of the variable, the x variable. It's a 1, right? Because there's nothing there. So the slope is 1. So these are different. These slopes are different, so I know there's going to be one solution. All right, very good. Moving right along. Okay, whoops, having some trouble here. There we go. All right, I want you to solve the following system by graphing. Okay, go ahead and try. When you're ready, watch me. All right, I'm going to graph this bottom one first because it's in slope-intercept form. And so I'm going to go y-intercept of 2. And I'm going to go rise 1, run 1, 2, 3, rise 1, 1, 2, 3, rise 1, 1, 2, 3. Let's go down 1 and left 1, 2, 3. And down 1, left 1, 2, 3. It's like I'm dancing, I'm dancing. All right, so I know this is the first line. Okay, looks like I'm off a little bit, but I'm just going to chalk that up to human error. And I'm going to put an arrowhead on the other end, and maybe I'll make it a wee bit thicker, and I'll make it blue. Okay, now for the other equation, it's in standard form. Well, let me go find the slope. So A, B, C. Easy as 1, 3, 12. So the slope is going to be equal negative 1/3. Well, I know there's going to be one solution because the slopes are different. This one was 1/3. This one's negative 1/3. Now I can find the x-intercept or the y-intercept. I think I'm going to go looking for the y-intercept. So I'm going to make x equal to 0, add 3y equals 12. It's going to be 3y equals 12, and I will divide by 3. And the y-intercept is going to be 4. So I know that it's going through the point 0, 4. So I'll plot that point, 1, 2, 3, 4. And then I will go down 1 right, 1, 2, 3. Oh, look what happened. Down right, 1, 2, 3. I know that the two lines are going to intersect at that point right there. How do I know? Because I got red and blue marks on the same exact point. All right, so let's go. Oops, I don't know what happened right there, pardon me. Let's see here, I'm having a little trouble. All right, properties, put an arrowhead on that, and we'll make him red. There we go. So it looks like the solution to this system is the point 3. 1, 2, 3, 3. There you go. There's your solution. All right. So now I want you to solve this following system using substitution. Remember, to do it, you have to figure out which variable you want to solve for first. Go ahead and pause the video and give it a shot. Here comes my solution. If you haven't tried it yet, please do so. All right. I think solving for y in this equation would be a good idea. And I also think solving for y in this equation would be a good idea. I don't like solving for x in either of these equations because the coefficient on x, 3 in the top equation, does not go into y or 4 evenly. The bottom equation, 6, doesn't go into 2 or negative 8 evenly. So I'm going to go ahead and solve for either one of these y's. I'll tell you what, I think I'm going to do the top equation, and I'm going to solve for y. So I'm going to have 3x minus y equals 4, and then I'm going to isolate the y. So I'll subtract 3x from both sides. and I'm going to get negative y equals 4 minus 3x, and then I'll divide by negative 1. Negative 1 divided by negative 1 divided by negative 1. And so then y is going to equal negative 4 plus 3x. Now I'm ready to substitute. I know what y is. It's the same as negative 4 plus 3x. So I'm going to substitute this in for y right there. So when I do that, I'm going to have a 6x plus 2. I'll have a quantity of negative 4 plus 3x, and that will have to equal negative 8. All right, so I'm going to get 6x minus 8 plus 6x equals negative 8, right? Got a couple choices here. Some of you like to get rid of that 8 first. I don't think that's what I would normally do first, but it's not a dumb idea. And so I'll go ahead and do it. And when I do that, I end up with 6x plus 6x equals 0. Excuse me. So, combining my like terms, I'll get 12x equals 0. Divide by 12, divide by 12, x is going to equal 0. Now, I like substitution so much because I always have that y equals equation or x equals equation. I know x is 0, so I'm going to go y equals negative 4 plus 3 times 0. If I simplify that, I get y equals negative 4. So the place where these two lines intersect is actually the y-intercept of both lines at 0, negative 4. All right. Level 2 kids, if you want to stop here, you can. If you want to keep watching, that's awesome. Go ahead and front load yourself a little bit. All right, I've got to solve this system by elimination. So I want the coefficients to be additive inverses of each other, like a positive 5 and a negative 5, or a 3x and a minus 3x. Now I don't see any easy way to do it. I do look at these y's and think, I know a number that both 2 and 3 go into, 6. If I multiply this top equation by 3, when I distribute, this will turn into a 6y. And of course, I've got to multiply the 14 by the 3. When I do the bottom equation, I'm going to multiply by 2. The only problem is, when I distribute that 2, I'm going to get a negative 6y. In the top equation, when I distribute the 3, I'm going to get a negative 6y. I want them to be opposite signs, additive inverses. So I'm not going to multiply by 2, I'm going to multiply by negative 2. And so my red equation is going to become 12x minus 6y equals negative 42. And then the bottom equation is going to become negative 18x plus 6y, and that's going to equal a positive 48. Now I like to add these equations together. And so I'm going to get a negative 6x. That's going to equal a positive 6. I'm going to divide by negative 6. So therefore x is going to equal negative 1. And the reason I don't like elimination is I've got more work ahead of me. I don't have a nice y equals equation. So I've got to pick one of these equations. I could pick this one, this red one, this blue one. I could pick the 4x minus 2y equals negative 14 or the 9x minus 3y equals negative 24 equation. I think I'm going to take the 4x minus 2y equals negative 14 equation because it's smaller. So I'm going to go with 4 times negative 1 minus 2y equals negative 14. Well, that's going to become negative 4 minus 2y equals negative 14. And then I'm going to add 4 to both sides. And that will give me the equation. Let me get a little more space here. Negative 2y equals negative 10. Dividing by negative 2 will tell me that y equals 5. So I know these two lines intersect at the point negative 1, 5. All right, that's it for the video. If you need to watch it again or you go back and watch part of it because you didn't understand something, that's awesome. Hopefully you took some good notes, and when we start you'll stay fresh on these problems. Mr. Lawrence signing off. Have a good night, everybody.